Hello, this is Brad Stravik, and I'd like to talk for several lectures about a case study in sustainable water use, or the lack thereof, as you'll have to decide for yourself. But we're going to start by applying quantitative mass balances to problems of sustainable development. In this case, we're going to look at the small island nation of Malta and their water use in that island nation. Malta is home to about 400,000 people. The groundwater supply there is stressed. It's an island nation, has a limited area for groundwater recharge and infiltration. In addition, there's increasing demand from population, but also from industry and tourism. Also, the climate's changing and sea levels rising, which has an impact on their groundwater table. In addition, there are sociological concerns that affect water use in Malta. There are many myths about where the water comes from in Malta that are misunderstood by the Maltese people. True or false? Does limestone remove salt from seawater? True or false? Is the groundwater in Malta replenished by the Nile River? True or false? Do deeper wells in Malta provide better water quality? True or false? Crops grown with reused water are not as good. True or false? The water supply is limited. Limestone does have many benefits for water supply. As we talked about in Chapter 2, it does neutralize acids, but it does not remove salt from seawater and does not make seawater drinkable. So that's false. The groundwater in Malta is not replenished by the Nile River. The Nile River lies across the saltwater body many hundreds of miles away. So that's not likely to help the water scenario in Malta. Malta being an island nation, which is basically resting on top a saltwater reservoir underground that fills the pore spaces, means that drilling a deeper well in Malta may not provide better water quality. In many places on a larger continent, this may very well be true as we tap into ancient sources of groundwater that have been stored long times ago and trickled down through many layers of water for purification. But in Malta, we'll see that there may be a discrepancy with going deeper to provide better water quality. Are crops grown with reused water not as good? Well, this is an engineering issue. How good is the water that we reuse it, and how do we use it to regrow our crops? Is the water put directly on crops that are eaten directly with the water on them? Or does the water go into the root system and is further purified so that possible minimal amounts of contamination from very high quality treatment will not interfere with crop growth? This is a question that has yet to have an answer, whether it's true or false, and depends somewhat on the how. And as you've already learned in this chapter, indeed, the water supply is limited. So in this section, we're going to use our basic water balance equation, or the Breit's equation, that precipitation is going to be a function of runoff, infiltration, evaporation, transportation, and storage. We're also going to look at consumption as part of this equation as well. If we look at Malta, there are areas of Malta that are protected, especially for groundwater infiltration. This is a significant percent of the island, but not all of the island. So much of the island that's undergoing development, any area that undergoes further development, such as having roofs put on the area, may decrease the amount of water that infiltrates into the water table. As we see in the right-hand figure, this is a floating groundwater body. So fresh water is lighter than seawater. Just like olive oil will float on top of water, fresh water, being lighter than sea level or seawater, will float on top of the salt water from the Mediterranean Sea. This creates in essence a bubble. So depending upon where we are within that bubble, whether we're close to the edge of the bubble, drilling down farther may not increase water quality, but actually add more salt to the water. whereas closer to the center of the island, at the highest parts, drilling down deeper may create more fresh water or higher quality water, but location and how we do this is going to be important. Furthermore, sea level is rising. It may rise 96 centimeters by the year 2100. This rise in sea level will further decrease the bubble of fresh water that underlies the island nation of Malta. So in order to understand the complexities of water allocation in Malta, we need to do a thorough analysis of the water budget. We need to know what the average rainfall is, and we may calculate this in meters per year, and what the average volume of water captured is, perhaps in cubic meters per year. So we'll look at the table of precipitation to determine this. This table was presented in a report by the Food and Agricultural Organization, part of the United Nations team that was investigating water supply in Malta. They measured yearly precipitation variations in rainfall from January to December over the course of a year. Take a moment now, go through these values, the rainfall values in millimeters, and determine the average rainfall concentrations. Pause the video, and when you're done with this calculation, move on to the next slide in the next video. Hopefully by now you've calculated the average rainfall concentration. One of the issues is that this average may change as the climate changes and over long periods of time, so that actual rainfall may vary quite substantially from year to year. This may affect evapotranspiration rates, runoff, and what's known as effective precipitation or effective rainfall, which is the rainfall minus the rate of evapotranspiration. Different authors from 1952 to 1991 have determined different amounts of rainfall, measured different evapotranspiration rates with climate variability, and this has led to different measures of effective rainfall. Notice that the minimum effective rainfall per year is measured as 95 millimeters, while the maximum is measured at 203. Increasing urbanization in areas of Malta leads to a decrease in infiltration rates and can change our water budget equation as well, perhaps changing in evapotranspiration, but also the areas of water can be captured and infiltrated into the groundwater table, which is basically the reservoir for the island nation of Malta. In order to complete our water balance, we need to balance the inflow and outflow from this underground water storage. So the inflow comes from precipitation. The precipitation can go to surface runoff to the sea, to evapotranspiration. It can also go to natural aquifer recharge, and artificial recharge from leaks in water systems, which in this case are somewhat sizable, so that the total groundwater inflow can be calculated as the sum of the natural aquifer recharge and the artificial recharge from leaks, or 57 hectare meters cubed per year. The outflow from this groundwater table is related to the groundwater extraction from the water service provider, WSC, private groundwater abstraction from private wells, as well as subsurface discharges to the sea where water is flowing from the groundwater table, that freshwater bubble, out into the Mediterranean Sea, so that total groundwater outflow is about 54 hectare meters cubed per year. Balancing this gives a total inflow of 57, a total groundwater outflow of 54, which gives us an allowable water sustainable use of 3 hectare meters cubed per year. This water balance has been done to some detail on different watersheds and catchment areas across Malta, as seen in this table, trying to measure the inflow and outflow of each groundwater aquifer. It's expected, though, that the demand for water in Malta may rise. We see substantial increases in the billed domestic consumption, although they have made progress through good engineering practice by decreasing apparent losses from runoff, leaks, and other processes. Domestic, agricultural, or private use has remained relatively stable, but water domestic demand is expected to increase into the future from 2006 to 2015 levels. This increasing demand, rising sea level, changing climate, all create significant water pressures on this tiny island nation of Malta. And there's such a small difference between the 57 and 54 in that table that small fluctuations in climate, which are actually observed in the precipitation data, could significantly decrease the availability of water for the Maltese population. We'll look closer at this in the next episode.